Okay, so when you want to solve an exponential equation, that is an equation that have the unknown in the exponent, the standard thing is to take log both sides and use the fact that if you take log of something that have exponents, that exponent becomes the coefficient. It's really a powerful idea that allows you to solve these things. But what about when you got an equation with logs in it? How do we solve an equation with logs? Well, one way you can do it is trying to get all the logs together and then use the properties of logarithms to write it into one big mama log. And once you got that, untangle the logs into exponential equivalent form and solve it. So the theme here is first we get one big log on one side and number on the other side, and then convert the log back into exponential equivalent form and solve that. Let me try to explain it to you and illustrate with some examples. But before I get into the example, I need to tell you something, a caution. This is a very important caution, and I really want you to listen to me on this. So whenever you have a log equation, you must always check your answer. Because sometimes you may have, just like a square root equation, you may have extraneous root. So we really got to be careful with the log that we got to check our answer. Right? I'll illustrate that the first time, and then for the other examples, I'll let you check it out yourself. Okay? So let's get to the first example. Example number 1. I have logs base 2 of x plus logs base 2 of x minus 3 equal to. Right. Remember, the thing here is to get one big log into one size, right? So I need to combine the two logs. And one of the properties of logarithm that allow me to do that is that when I see the sum of logs, that is the logs of the product, right? So if you remember this, I have logs A plus logs B is equal to logs A times B, right? And assume that they have to have the same base. So this becomes logs base 2 of x times x minus 3 equal to. Okay. This equivalent to logs base 2, I'm going to distribute the x. So this becomes x squared minus 3x equal to. Okay, now we have one single log. I want to convert this log equation into exponential form. Right? So remember your definition of logs. Log is an exponent that I have to raise 2 to. So this right here is an exponent that I have to raise 2 to in order to get log. Right? So that's a little arrow right there. I hope it's helpful. So when it comes to the exponential form, I got 2 squared equal x squared minus 3x. Well, 2 squared is 4 equal x squared minus 3x. And now from a logs form, we come down to a familiar quadratic form. So let me rewrite this. X squared minus 3x. I'm going to move the 4 to the right-hand side. Minus 4 equals 0. And I believe this is factorable. So I need two numbers that when I multiply get me negative 4 and add up get me negative 3. That'll be 4 and 1, or better yet, negative 4 and positive 1. And now my solution is either x equal negative 1 or x equal 4. Okay. Two possible solutions. Again, like I said before, it is not an official solution until you check it. Okay. So let me do a little check box here. Check. I'm going to check x equal 4 first. Right? So I'm going to plug x equal 4 back into the original equation. Not this one, not this one, this one, right? That's your original equation. So whenever I see an x, I replace it with 4. So I got log base 2 of 4 plus log base 2 of 4 minus 3. And I hope it is equal to 2. So log base 2 of 4, I can rewrite it as 2 squared, right? And log base 2 of 4 minus 3, that's 1. Right? Well, log base 2 of 2 squared, this one and it's log base 2 and the 2 cancels. So that's leave me just 2. Log base 2 of 1, that's just a standard form. What power when I raise to 2 give me 1, 0, right? So this is in fact equal to, check. So x equal 4, it is your check answer. Now I'm going to check x equal -1, right? Okay. Now when I plug in x equal -1 into the original equation, I see a major problem. That is, I have a log base 2 of -1. And remember the domain of log, do you guys remember the function of log? Its domain is from 0 to infinity, right? It's never past 0 to the negative side. So you cannot have a negative logs. Therefore, this is not your solution. It is a extraneous solution. That's why it's really, really important that we check our answers when it comes to logs equation. Okay. Let's go to another example. Example 2. I have ln of x equal 1/2 ln of 2x plus 5/2 plus 1/2 ln of 2. Well, this is the big one. Remember, we want to bring log together, right, into a single form. So let me rewrite the left-hand side. So ln of x. On the right-hand side, before I can combine the log, I need to move the 1/2 back into the exponent. Right? Remember the power rule is allow me to move the coefficient back to the exponent. So this becomes ln of 2x plus 5/2 to the 1/2. Right? Same thing here. I can move the 1/2 to its exponents plus ln of 2 to the 1/2. Rewrite the left-hand side. Now I can combine the right-hand side, right? So this is the sum of log. So that is the log of the product. So I have ln of 2x plus 5/2 times 2 to the 1/2, all of it to the 1/2. Right? And now I'm going to move ln of x to the right hand side. So when I do that, the left hand side that's just 0, right? And the right hand side I have ln of 2x plus. I'm going to distribute the 2 into this 2 so to I don't have to rewrite that. So this becomes 4x. 2 times 2x is 4x plus 5/2 times 2, that's 5 to the 1/2, right? Minus ln of x. Okay, looks good. Again, I need to combine these two logs. And when you see a difference of two logs, it is the logs of a quotient, right? So this become ln of 4x plus 5 to the 1/2 power is the same thing as saying is the square root, right? Over x. Right? So from here to here, let me put a little note here. From here to here, I use the rule. If I have log a minus log b, it is equal to log a divided by b. Okay? Now, I want to get rid of the ln, right? So how do I do that? Well, I'm going to raise both sides by e, e. On the left-hand side, e to the 0, that's just 1. On the right-hand side, because e and ln are inverse functions of one another, so those two guys are cancel each other, leave me just square root of 4x plus 5 over x. Okay. Now I want to get rid of the x in the denominator. I'm going to multiply both sides by x. Right? Multiply both sides by x. On the left-hand side, 1 times x is x. On the right-hand side, the x cancel, so that leaves me just square root of 4x plus 5. Well, I need to solve for x, so I need to get rid of that square root. So I'm going to square both sides. Square both sides. Okay. The left-hand side is x squared. The right-hand side, the square and the square root cancel, so leave me 4x plus 5. And now we're going to move 4x and 5 to the left-hand side, so we can get a quadratic equation. And this also factorable. I got -5 and +1. So my solution is x equal -1 or x equal 5. Right? And again, you must check before you call this your official answer. So when I plug in x equal -1 into the original, I have ln of -1. Again, we don't want a negative for log, right? Because the domain of logs from 0 to infinity. So this is not your answer. But I'll let you check and verify that x equal 5, in fact, an answer. It is an answer, but I'll let you check and verify that. And remember, a log, just like a square root, you finish until you check. Okay, see you up next.